Hey guys, this is Nick from Groupware here. Today we're going to be doing the second video in our series on NVIDIA Clara Parabricks. Specifically today, we're going to be talking about the Germline pipeline. Today we're going to be doing a genomic sequencing demo using the NA12878 dataset. It's a very well-known dataset, which will be an excellent benchmark for demonstrating the increase in computational speed and performance. So let's get right into it. So we've gone ahead and written up a document outlining this whole process. It goes over software requirements, hardware requirements, the installation process, testing your environment, a little bit about the Germline pipeline itself, including inputs and outputs, downloading the data set, setting up your scripts, and then finally running the pipeline. And this video is going to be basically going over this document and showing you what that might look like. So for software requirements, we're going to need a few things, most of which can be installed on any Linux machine. We're just going to need to make sure that said Linux machine supports CUDA. For the full software specifications, see the NVIDIA Parabricks Quick Start Guide. And then for the hardware requirements, this is a little bit more stringent in the sense that you need a machine that can run Parabricks. So it's been tested on NVIDIA P100, V100, and T4 GPUs. But in theory, it can run on any GPU that supports CUDA architectures 60, 61, 70, or 75, and has at least 12 gigs of GPU RAM or more. And then there's a little resource guideline here. Based on how many GPU servers you have, it says how many CPU RAM you should have and how many CPU threads you should have. And again, for full hardware specifications, check out the NVIDIA Parabricks Quick Start Guide. So in this video, I'm going to go ahead and gloss over installation, since this is more of a demo video than an installation video. But within this document, we give you some resources, the overall process, who you need to reach out to at NVIDIA, and how to actually install, as well as link to the full installation instructions on the NVIDIA Parabricks Quick Start Guide. So for the sake of this video, I'm going to go ahead and assume that you already have Parabricks installed. Okay, so now that we have our Parabricks installed, we're going to go ahead and test the environment just to make sure that everything is running as intended from a software and a hardware point of view. So we're going to be using this sample data set that they supply, as well as a sample reference genome. So we're given 2 FASTQ files, as well as the reference genome to compare against, and a time. So this whole test should take under 250 seconds, and on using 4 V100 GPUs. And on our DGX1 system using 4 V100 GPUs, the test completed in about 210 seconds on average. If you're getting significantly higher runtimes, you might have a configuration issue, so be sure to make sure that everything is configured correctly. For full instructions, you can see the NVIDIA Parabricks Quick Start Guide. So as stated previously, for this demo, we're going to be using the Parabricks Germline pipeline. It's geared towards analysis of genetic variations that are present from birth, such as those you might get from your parents. Given 1 or more FASTQ files, you can run the Germline variant pipeline workflow to generate output, including variants, BAM, and recall. So we can see the inputs to the pipeline here are BWA index reference files, pair-ended FASTQ files, and known sites for BQSR calculation. And then the outputs are aligned, coordinate sorted, duplicated marked BAM, BQSR report, and then variants in the following formats. So a little bit more about the pipeline. This is the architecture, which resembles the GATK4 best practices pipeline. Let me go ahead and zoom in here a little bit. So we're going to go ahead and start with the FASTQ files, which are going to go into BWA memory alignment, coordinate sorting. It's going to Picard mark duplicates and do base quality score recalibration. Then we're going to go into BAM and CRAM. From there, we're going to apply the base quality score recalibration and haplotype color. And then finally, we're going to get our output variants. So for a full overview of the Germline pipeline, go ahead and check out the NVIDIA Parabricks documentation. Okay, so now that we have a bit more of an understanding of the pipeline itself, we can go ahead and download our dataset. As I said previously, we're going to be using the NA12878 dataset. It's a well-known dataset and will be a good benchmark for demonstrating the performance of Parabricks. We're going to need this dataset in the FASTQ file format, as well as a reference genome to compare against. So we can get these using the following wget commands to download from S3 buckets. So these two are for the FASTQ files, and this one is for the reference genome. Keep in mind the download process may take some time. Together, the FASTQ files are about 77 gigs, and the reference genome is about 4.3. From there, the NA12878 FASTQ files can be left in their zipped file format, but the reference genome must be unzipped to be used. So go ahead and unzip it using the following tar command. This will create a directory called ref, and just go ahead and leave this in your main directory. Okay, so we're nearly there. We're going to go ahead and set up our file structure as it should be, as well as some of our scripts to run the pipeline. So we're going to go ahead and create a data and output directory. And as you might suspect, we're going to put the data in data and output in output. So this is what your file structure might look like. We have a data directory, an output directory, and the reference directory, which we got from untarring the reference genome, as well as this run pipeline file, which we're going to create in just a second. Within the data directory, we're going to have our two FASTQ files. Output's going to be empty right now until we actually run it. And then reference is going to have all of our reference genome files. And then finally, we're going to go ahead and create this run pipeline.sh file to actually run our pipeline. And this is the Parabricks command itself. So here we have sudo. We require this on our machine. It might not on yours. Time, this is the Unix time command, just to test how long everything takes. And then pbrun, Germline, which is the Germline pipeline. And then we have a bunch of parameters. So ref is the reference file, genome. In FQ are our FASTQ files. And then we have some outputs. So out recall file, known sites, our out BAM, as well as out variants. And then finally, we have the number of GPUs. So we're running this on a DGX1, which has 8 V100 GPUs. And we're going to go ahead and use them all. And then finally, all of this is going to be outputted to a log file. So you can save this log file to come back to, make sure everything ran as intended, or just to have around for posterity's sake. So all of this is going to go ahead and run our pipeline command and output it to a log using 8 GPUs. And additionally, it will output the total number of time taken because of this Unix time command. Okay, so we're finally here, moment of truth. We can go ahead and finally run the Germline pipeline on our NA12878 dataset. This is as simple as adding execute permissions to our bash file and then going ahead and running it. Since we designed this to output to a log file, you're not actually going to see any output when you run it. If you want to see the script run in real time, go ahead and open up a new terminal and use this command here to output the last 50 lines of the log file as the script runs. When it starts, it might look something like this, and when it finishes, you might see something like this. I'm going to go ahead and insert a pre-recorded video of the actual run. It took about an hour to an hour and 10 minutes to run, but it has been sped up significantly so that you guys don't have to sit through that. Okay, and we finally got there. We have run the NA12878 dataset on the NVIDIA Parabricks Germline pipeline. On our DGX1 system using 8 V100 GPUs, this took about an hour to run. Your runtime may vary. So in addition to the log file from the run, we have all of our output files. This is what your file structure might look like now. We have all the same things as before, but we also have this out.log file, as well as our output directory has been populated. So that is it. You've now completed running the demo. Feel free to reach out to us if you have any questions or run into any issues. Thank you.